Hello everybody, this is Homework 1 Part 2. We're going to look at a water phase diagram and talk about a little at-home experiment. So I'm going to pull up the water phase diagram and here we go. Okay, so the water phase diagram is basically just a diagram explaining at what temperature and what pressure what phase water will be at. So we look here, our x-axis, that is going to be your temperature in Celsius, and the y-axis is our pressure in atmospheres. So just a quick explanation of this. We can see water, liquid, water vapor, and water solid ice. So just a quick explanation. So, for example, if you had a water at 50 degrees C right here, and at 1 atmosphere, we would fall in the liquid category because obviously everybody knows, water at 50 degrees C at our atmosphere is liquid. But if we go past 100 degrees C, which we know is the boiling point of water at our atmosphere, we fall in the water vapor or the gas section, which does in fact make sense. And then if we come to the freezing point of water, 0 degrees C, and at 1 atmosphere, we are at water solid ice. And then we have the critical point, that's basically at 218 atmospheres and 375 degrees C. That blurs the lines between water and water vapor, but we're not talking about that today. Today we're talking about the triple point. So the triple point, all the way down here at 0.006 atmospheres. So in order to reach the triple point, you have to be pulling a vacuum, and that is at 0.1 degrees C. But what is the triple point? The triple point is where solid water, ice, liquid water, and gaseous water, water vapor, all exist at the exact same time simultaneously. So, in order to get to this point, we have to pull a vacuum on the water and have it at 0.01 degrees Celsius. But we have to do this in our kitchen, not in a lab. So you might be wondering, how do we think we're going to do this? Well, the way I think I would do this is I would put boiling water in a cup. Sorry, I don't have a water bottle, but this is my trusty water turvis, so I'll use this as our example today. I would put boiling water in this turvis. Why would I do that? Well, because when we do that, boiling water lets off water vapor, so that when we put it in this container, the rest of the container would be filled with water vapor, hot water vapor, and not oxygen. So once this is boiling and I feel like I've waited enough time for it to fill up with water vapor, not oxygen, I would cap it off and trap that hot water vapor in this container. I would then proceed to let that boiling water cool down, and then I would put it in the freezer. What that is going to do is it's going to cool down the water, freeze the water, and also cool down the water vapor, hopefully condense it. And what that's going to do is when water vapor is hot, it takes up a lot more volume. But when it gets colder, the volume it takes up shrinks. And if this lid is on tight enough, it would pull a vacuum on this container. So when that happens and the water is completely frozen and it's below 0 degrees Celsius, you would pull it out of the freezer and wait for it to hit 0.01 degrees Celsius, and hopefully our vacuum has 0.006 atmospheres. I don't know if that's even possible, but that is how I would go about trying to get to the triple point of water. Ideally, we would be in a laboratory and we would have, we would be able to pull a vacuum much easier and be able to control the temperature a lot easier. But if I was just in a standard kitchen, that is how I would do it. So thank you very much, and have a great rest of your day.